students, welcome to Succeed e-learning app. Polynomials. Hello students, I hope you all have learned what is polynomial in your earlier standards. Now let us recall what is polynomial. What is polynomial? Before we understand what polynomials are, let us understand the concept of terms and conditions. Let us consider an example of 13xy plus 5z minus 6. This whole together is called as an expression, and here plus and minus symbols are separating the terms 13xy, 5z and 6. This is called as terms and whole together is called as an expression. Now let us consider one more example of 15x square y minus 9y cube. Here 15x square y minus 9y cube whole together is called as an expression, and 15x square y and 9y cube are called as terms which are separated by minus symbol, and 15x square y comma 9y cube are called as terms which is separated by minus symbol. Now let us move on to the important concept of algebraic expressions called as polynomials. Here poly means many and nomial means terms are parts. That is how polynomials are defined, or comes out as many terms in simple. There are different types of polynomials. A polynomial can be of one term, two terms, three terms, or even higher number of terms. All these categories comes under one root called polynomials. Expressions with one term, two terms and three terms are given special names. Expressions with one term is called as monomial. Here mono means one and nomial means terms are parts. Now let's see the second type of polynomial. Expressions with two terms are called as binomial. Here bi means two and nomial means parts are terms. Now let's see the third type of polynomial. Expressions with three terms are called as trinomial. Here tri means three and nomial means terms are parts. These are the types of polynomials. There is always a misconception stating that expressions with more than three terms are said to be polynomials, but it is wrong. Expressions with one term, two term or three term and even higher number of terms are said to be polynomials. Now let us look out some examples of polynomial. Examples of monomial. Here number 5 is a monomial having only one term, and even number 3x is also a monomial having 3 multiplied by x whole together is called as term. Let us now look out the examples of binomial. Here 9 plus x is a binomial which is separated by plus symbol. Let us see the example of trinomial also. The example of trinomial would be 2 plus y plus x. Here there are three terms which are separated by 2 plus symbols. Now let us finally look out the example of higher number of terms in polynomial. The example of higher number of terms would be 10x plus y plus 9y plus z. Here there are four terms which are separated by plus symbol. By seeing all these examples, now you will able to differentiate each examples of polynomial. Degree of polynomial. Hello students, in the earlier session we have learned what is polynomial. In this session, we'll be knowing the important concept of polynomial known as degree of polynomial. Polynomials. In polynomials, there can be only two broad categories. First one would be one variable. Second one would be more than one variable. Now, let us understand these categories individually. First, consider one variable. Let us see this with an example. Consider the example of 10x to the power of 5 plus 9x squared plus 3x minus 4. Here, as all of you can observe, there is only one variable, that is x. So, all this together is known as one variable. Now, let us understand the second category, that is more than one variable. Let us consider the example of 10x squared y plus 5xy plus 9z plus 2. Here, there are three variables, that is x, y, z, which are called as more than one variable. Now, let us understand the second category, that is more than one variable. For understanding this concept, let us take an example of 10x squared y plus 9x squared y plus 10z minus 4. Here, as you all can observe, there are three variables, that is x, y, z. Now, what about these two categories? Why did we form them? It is because the concept which we are going to learn today, that is degree of polynomial. In the first category, we have taken the example of 10x to the power of 5 plus 9x squared plus 3x minus 4. In this expression, there is only one variable x and degree of that variable is largest exponent of that variable. Now, is it any difference in the second case? Yes, slightly different. Now let us see the second category of more than one variable. In this case, for each term, we add the exponents of variable in it. Now, let us see how will it work for the example of 10x squared y plus 5xy plus 9z plus 2. In this example, remember that we have to see each term individually. This is the simplest session to understand the concept of degree of polynomials. Why don't you all try the different examples to understand the degree of polynomials? Consider the first term 10x squared y. Here, there are two variables, that is x and y, and the exponent of x is 2 and the exponent of y is 1. So, on adding the exponents of x and y, we get 2 plus 1 is equals to 3. So, the exponents of x squared y is 3. Now, we come to the second term, that is 5xy. Here also there are two variables, that is x and y. The exponent of x is 1 and the exponent of y is 1. On adding the exponents of x and y, we get 1 plus 1 is equals to 2. Therefore, the exponent of xy is 2. In the third term 9z, we have only one variable z and the exponent of that variable is 1. So, the exponent of this term is 1. As all you can see, there is one more term in the expression, that is 2, and there is no variable in it. If there is no variable, then the exponent of that term would be 0. As we have found the exponents of each term individually, we can compare which is the largest one. Here, the largest one is 3. Therefore, the degree of this expression would be 3. And remember, a polynomial of degree 1, 2 and 3 are called as linear, quadratic and cubic polynomials respectively. Hope you understood the previous concept, degree of polynomials. Now let us learn zeros of polynomials. What are zeros of polynomials? Confusing, right? Let us try to understand it. Consider an example of p of x is equals to x plus 5. Here, what value of x will make p of x is equals to 0, such that the value of polynomial equals to 0. Now, what do I use in place of x such that x plus 5 is equals to 0? Here, it is a simple linear polynomial, so we can say x is equals to minus 5. If x is equals to minus 5, we get p of x is equals to minus 5 plus 5, which is equals to 0. So, minus 5 in place of x gives us p of x is equals to 0 in this example. Hence, minus 5 is called as the 0 of polynomial of this expression. Remember, 0 of the polynomial is the number when substituted in place of x gives the value of polynomial equals to 0. Generally, the number of zeros of polynomial depends on the degree of polynomials. In the above example which we considered, p of x is equals to x plus 5. Here the degree of polynomial is 1. Hence, the zeros of polynomial will be also equal to 1. This is the simple concept to understand the zeros of polynomials. In the earlier concept, we learnt about zeros of polynomial. Now, let us learn the relationship between zeros of polynomial and coefficients of polynomials. Relationship between zeros and coefficients of linear polynomial. Now, general form of linear polynomial is ax plus b is equals to 0. Here, x is a variable and b is a constant. 0 is equals to minus constant term divided by coefficient of x, which is equals to minus b divided by a. Let us understand this with the example of 3x plus 6 is equals to 0. Here, to find the value of x, we will send plus 6 to right hand side. We get 3x is equals to minus 6. Now, let us send 3 also to the right hand side. As 3 is multiplied by x, it divides on minus 6 on right hand side. That is, x is equals to minus 6 divided by 3. So, we get x is equals to minus 2 after division. Now, we got minus 2 in place of 0. Now, this minus 2 should be equal to minus b by a. In example, 3x plus 6 is equals to 0, constant term is plus 6 and coefficient of x is 3. So, substituting we get minus 2 is equals to minus 6 divided by 3. Minus 2 is equals to minus 2. Here, the left hand side is equal to right hand side. This is the relationship between zeros and coefficient on a linear polynomial. By this example, we can easily understand the linear polynomial concept. Hope you understood the relationship between zeros and coefficients of a linear polynomials. Now, let us see the relationship between zeros and coefficients of quadratic polynomials. Now, general form of quadratic polynomial is ax square plus bx plus c is equals to 0. Here x square comma x is a variable and c is a constant, and sum of zeros is equals to minus coefficient of x divided by coefficient of x square, which is equals to minus b by a. In this we will get two zeros as the degree of polynomial is 2 and it is quadratic polynomial. Similarly, product of zeros is equals to constant term divided by coefficient of x, which is equals to c by a. Now, let us take the example to understand this concept. Consider the example of x square plus 3x plus 2 equals to 0. It's a quadratic polynomial. Now, let's find its zeros by factorization method. So, the factors we get in next step is x square plus x plus 2x plus 2 is equals to 0. Taking common in first two terms, we get x into x plus 1 plus 2 into x plus 1 is equals to 0. In this, the factors are x plus 1 and x plus 2. X plus 1 into x plus 2 is equals to 0. Now, let's find zeros of factors. So, x plus 1 is equals to 0. By sending plus 1 to right hand side, we get x is equals to minus 1, and x plus 2 is equals to 0. By sending plus 2 to the right hand side, we get x is equals to minus 2. So, the two zeros which we got from quadratic polynomial is x is equals to minus 1 and x is equals to minus 2. Now, let us verify by using formula sum of zeros is equals to minus coefficient of x divided by coefficient of x square, which is equals to minus b by a. So, for the sum, let us add the factors we got, that is minus 1 plus minus 2. We get minus 3. So, minus 1 plus of minus 2 is equals to minus 3. Minus 3 is equals to minus 3. Here, left hand side is equals to right hand side. Now, let us see the product. Here, minus 1 into minus 2 is equals to 2 by 1. 2 is equals to 2. Here, left hand side is equals to right hand side. So, this is the important concept, and remember the sum of zeros and product of zeros in general form. Similar way, we can try for cubic polynomials by considering the general form of p of x is equals to ax cube plus bx square plus cx plus d, and sum of zeros is equals to minus coefficient of x square divided by coefficient of x cube, and product of the zeros is equals to minus constant term divided by coefficient of x cube. This will help you to find the cubic polynomial value. You can try with an example for the cubic polynomial values. Now, let us summarize what we have learnt in this chapter called polynomials. We have learnt about what are polynomials, types of polynomials, degree of polynomials, zeros of polynomials, and relationship between coefficient and zeros of polynomials. Okay, here ends our chapter polynomials. Hope you understood. And for further chapters, keep watching Succeed e-learning app.